So presently, as you all are aware, that we are going through our series of programming in Java, and the current topic which we are studying is about exception handling. So before this lecture, we have covered some of the lectures about the exception handling and what is actually the base, what actually the exception handling mechanism is, and what are the related keywords which are being used in Java for the process of exception handling, the basics, and some of the programs we have already seen. And now today we are going to proceed on in this particular topic only, which is exception handling in Java, and we will be looking into some keywords like finally, then in the next lecture we will be looking into throw. But let us begin with the concept of nested try block. So, what actually a try block is, that we have seen in our previous lectures, that basically whatever the code is which is suspected of throwing an exception or throwing an error is being is actually inserted in the try block. Now, the concept here says the nested try block in Java, and what actually we want to elaborate, or we want to present here through this particular topic is, we can use a try block within another try block, and that is a perfectly permitted scenario in case of Java, and that is what you call the nested try. Now, what is the need of the nested try thing? Why do you want to, or in which scenarios you want to use the nested try thing? That we will be covering, and also the example. And in order to manage this nested try thing, because one try is being kind of enclosed or being placed inside the other, the context of every exception is pushed onto the stack, and this is the way this is the idea through which the exception is handled, one after another they are pushed onto the stack. Now, coming to the idea or the logic that when to use this. So, wherever we need, wherever a situation arises in which a part of block may cause one error and the entire block itself may cause another error, we need to use the nested thing, nested try thing. So, in such cases exception handlers, which is a try catch mechanism here, have to be nested, and one try along with multiple catch situation we have also explored in our previous lectures. So, let us try to see this with the help of a general format, and then a very specific example that how this nested try is going to be used. So, here is a general format which is given on the screen. So, this says try statement 1. So, this is basically one statement which is given inside the outer block try. Then we have the next try which is enclosed inside the outer try, and within that we have another statement. I have named it as a statement 3, and then one another nested level. So, that means total 3 levels of try. The third try within the second try within the first try block. Each is having a different statement, and those statements are actually we can say suspected of throwing the errors or throwing the exceptions. Then the internal try, the innermost try, which is the third try, is bounded or is bind with the catch having the exception object as E2. Then the second level try is actually bound with the catch exception having object as E1, and the outer try block or the outermost try block is binded with the catch block, which we have written inside written within our comments, which says catch block of parent outermost or the parent try block, and there we have kind of the third catch. So, here one try within another try and the third try within the second try, and all the catch mechanism are binded with individual try, and how to recognize or how to take a flavor, take a feel of which catch is with which particular try. That is why I have given a proper indentation here. So, here you can see that the outermost the innermost try, which is written with the statement 5, is kind of indented in line with the catch exception E2. The try with statement 3, which is the middle level try or the second level try, is properly indented with catch exception E1, and the outermost try block for which the proper comment has has been given already, is being in line with the catch exception E3 thing. So, this is going to be the general format when we want to use the nested try, which is one try within the another try. So, for example, here the situation could says the internal try, which is which is with a statement 5, may throw some other error, then try statement 3 may throw some other error which is to be caught by the exception E1. The innermost try, the error which innermost try is going to throw can be caught by the exception E2, and the statement 1, which is which is inside the outermost try, may throw another another exception, and that can be handled by the exception E3. So, this is what the we can say the hierarchy or the nested level in which your try block is going to be executed or going to be placed within one another, and it is thus forming a nested try block. So, this was actually we can say a general format in which a nested try block is going to be capped or is going to be written programmed. So, let us try to implement this with the help of an example. So, here we have a class which is known as nested try block is the name given to the class. Inside that we have a usual main method, which is our public static void main along with the string arguments. Then we have a outer try block named as try, and then within that try we have another try block in which we are going to kind of generate an exception. We are going to deliberately generate an exception which is divide by 0, and this is to be done with the help of an statement which says integer b is equals to 39 by 0, and just before that statement we have written system.out.println going to divide by 0, and all these comments or all these println lines are going to help us in order to trace the execution of the program properly. Then we have catch of the inner try block. So, here we have two try blocks, one placed within the another, and the internal try block is throwing an exception which is going to be obviously a divide by 0 exception, as we can see here in the statement integer b is equals to 39 by 0. And in order to handle that exception, we have a catch clause which says catch arithmetic exception E, and this divide by 0 is going to be handled by this arithmetic exception E, and then that system.out.println, because we want to print the status or we want to print the contents of that object or that variable E. And then after that we have one more try block, which is the try or we can say the second try inside the outermost block. So, the outermost block we have one try, another with that try we have its catch block. Now, the next try, and that try is going to is going to throw an exception of array index out of bounds exception, what we call. So, here it is that try, and we have we can say declared an integer array A, which is of 5 total 5 of size 5, and the indexing, as you all are aware, goes from 0 to 4. And then for the fifth, which is A5, we are trying to assign the value, and this A of 5 is actually not available. The indexing which is available here is from A of 0 to A of 4. So, this particular statement which says A of 5 is equals to 4 is going to throw an kind of we can say exception, And what kind of exception it is going to throw? It is going to throw an array index out of bounds exception. In order to handle this situation, we have placed one catch block just after this try, which is catch array index out of bounds exception E, and it is actually doing nothing but printing this system.out.println E. That means it is printing the contents of the object E. And after that catch block, we have printed, we have given one print line, which is system.out.println other statement. So here in this program, till now we have seen one try block, then one try block within that try, which is about divide by 0. The corresponding catch also is being placed. Then after finishing of that catch, which is with the first try, the next try is about array index out of bounds exception, and the catch corresponding to that second try is also being placed with the corresponding try. But the outermost try inside which the two different try blocks are being placed is still missing. So, in order to complete that, we are going to place one more catch block of outer try block, and that is nothing but which is given here on the screen, which says catch exception E. And as you all are aware that this exception is, we can say the outermost or the parentmost class for all the exceptions. So, here whatever exception if any comes up will be caught inside this particular block if not handled within the try nested try blocks. So, here it says system.out.println handled the exception inside the outer catch or outer catch, and then a normal flow or a statement printing the normal flow is being printed. So, when we are going to run this program, what all kind of exceptions are being kind of we can say thrown. So, first of all, this inner try block 1, which is inner try block 1 is being executed. This is going to throw divide by 0 error or divide by 0 exception. Before throwing that exception, going to divide by 0, the statement will be printed. Then an exception will be thrown, which is being which is going to be caught by this arithmetic exception E, which is the corresponding catch. After completion of this inner try block 1 and the respective catch, the control will go to the next inner try block 2, which is again going to throw one exception of the array index out of bound exception. Corresponding catch is also available there in order to handle that, and these two exceptions are thrown, exceptions are handled by the corresponding catches. Then system.out.println other statement will be printed. Then this catch exception E is actually has nothing to do because there was no statement inside the outermost try block which is going to throw an exception, and this catch will handle that. There is no such scenario. And then the last statement, which is says system.out.println normal flow, this will be printed. So, the output which we are expecting should be something like that, going to divide by 0. Then whatever the whatever the state of E arithmetic exception E object is, that will be printed. Then the next exception, which is array index out of bounds exception, all those details of that particular object E will be printed. Then the statement saying other statement will be printed, and in the last the normal flow this clause should be printed. And here is we have this output which is going to divide by 0 first, then we have the exception handled, which is the divide by 0 exception. Then we have array index out of bound exception, which is again handled, and the contents of object E being printed. Then we have the statement, and then we have the other statement, and then we have the normal flow. So, this was actually we can say is the output which is expected, and we have got. So, here in this program what we have seen is we have taken one outermost try block, and within that try block we have placed two two more try blocks, not within one another, but try block 1 corresponding catch and then try block 2 corresponding catch. And here, when any try block does not have a catch block for a particular exception, then the system ensures that the catch block for the outer or the parent type try block are checked for that exception. So, for example, whether within this try block 1 in a try block 1 or in a try block 2, if we are not going to place any corresponding catch, then the catch block of the outer try block, or we can say the parent try block, will be checked for that exception, and if it is matches, the catch block of the outer try block is executed. This is the reason that why the outer try block here in this program has been given the class as exception E. So, whatever exception, even if the programmer fails to handle inside the try blocks, we are going to handle this as the within the catch of the outermost try block. So, that solves the purpose of placing a catch exception class E here. Now, if none of the catch block is specified in the complete code is unable to handle the exception, then the Java runtime system will handle the exception, and this is what we can say a normal flow of the exception handling. If an exception or if a catch block, corresponding catch block is provided by the programmer within the program as the part of the coding, then it is fine. But if no such catch block is specified in the code and the catch block or the code is unable to handle the exception, then the Java runtime system will handle that particular exception, and then it displays the system generated message for that particular exception. Now, please recall the previous classes in which we have gone through the keywords, that what all are the keywords which are being used when we are trying to handle or when we are trying to learn the mechanism of exception handling. So, the keywords there were 5 keywords: try, catch, throw, throws, and finally. And what we have seen till this point is we have done with try, then we have seen nested try, we have seen the catch block, we have seen multiple catch blocks within a single try block, and we have also seen a part of checked and unchecked exceptions. Now, the next after this the next keyword which we are going to read here is about the finally. The keyword is finally, but we are going to read we are going to learn this as the finally block. Now, what is the situation in which we are going to use this finally block? So, the finally block here is actually kind of a block which is going to handle or which is going to keep the code which is kind of, we can say, a cleaning code. What do I mean by cleaning code? That I am going to tell you in a short while. So, this finally block, first of all, it is used to execute the important code such as closing the connection. So, for example, we have established a connection between the Java application program and let us say a database. So, come what may, it is the responsibility of the programmer in order to have a clean exit to the program that the connection should be closed. And even if there is a kind of unhandled exception, then also the connection has to be closed. So, all those type of important codes which are kind of, we can say, mandatorily should be executed are kept inside the finally block. Now, why? The reason lies here. The Java finally block is always executed whether an exception is handled or not. Irrespective of exception is going to be handled by the Java runtime system, or it is going to be handled by the code written by the programmer, or even if it is kind of not handled, in any of the cases Java finally block is always executed. So that's why I told you that this finally block will contain all the necessary statements that need to be printed, that need to be executed regardless of the exception occurs or not. And now the question comes up, where are we going to place this finally block? This finally block actually, in the placement, it follows the try catch block, and here is a flow chart of the finally block, which you can see that there is kind of some code. If a kind of exception is being thrown, if an exception is being generated, yes, then this is going to be handled by the catch block, which is shown on the right side. Then even after this catch block, the yes branch of the catch block is coming to the finally block, even if it is not handled, then also the control, if you can see, is coming to the finally block. Apart from this, the outer condition, even if the exception is not generated, then also the we can say the control or the branch is coming to the finally block. So all the three situations, whether the exception is being generated, if yes, handled, yes, then also the finally block will execute it. Exception generated but not handled, then also the finally block will execute it. And even if the exception is not generated at all, not raised at all, then also the finally block is executed. So here this whole process is being shown here with the help of a flowchart. Now on the basis of this situation, or on the basis of this explanation, we can say that finally block in Java is going to be used to put up all that cleanup code. For example, as I have told you, that closing a connection, or it could be kind of a closing a file properly. All those important statements which are to be executed, or we can say which must be executed before ending the program, must be placed inside the finally block. Now, what all are the usage or the case scenarios in which the finally block is going to be used, and how? So basically there are three usages of this Java finally keyword. The first is when an exception does not occur, as we have seen, no exception occur, then also we can use the finally block. The second statement or the second scenario says when an exception occurs but not handled by the catch block. Catch block is not available there to handle that exception. Then also your finally block comes into the picture, or then also the finally block can be we can say can be used. And the case 3, when an exception is occurred and handled by the catch block, then also we can use finally thing for our for placing our cleanup code. So first of all, let us take the case 1 where an exception does not occur at all. So what could be the possible program, or what could be the scenario, what could be the example? Let's see this on the screen. So there we have a class, we have named it as test finally block, and then we have a main thing. Within the try block, we have integer data is equals to 25 divided by 5, and system.out.println data, which is a simple division. It is not going to throw any exception because it is not a divide by 0 thing or something of that sort. And then the corresponding cat says null pointer exception. Obviously in the try block there is no such code which is going to throw a null pointer exception E, and within the catch block we have print that statement E as per our kind of routine routine programming exercise. And after this catch block we have placed the finally thing, and within the finally the statement says system.out.println finally block is always executed. And then after we can say after this finally thing, after this finally block, we have also written one system.out.println which says rest of the code. So, when are we going to compile and run this program? This try block is not going to throw any of the errors, because data integer data is equals to 25 by 25 by 5 is a simple arithmetic statement which will be executed without any exception being thrown. So, catch null pointer exception is not going to be used, because there is no such exception inside the try, but the finally statement will be executed, and whatever is written inside the finally will be executed. So, here we have written system.out.println finally block is always executed. So, after printing the value of data as written inside the try block, the finally block will executed, and the statement finally block is always executed will be printed here in this scenario. So, in this particular lecture we have started with the concept of nested try. We have understood that with the help of a general format as well as with the help of a particular program. Then we have started with the finally, and we have seen in brief the use case scenarios for finally, and we have explored one usage of Java finally where the exception is not at all occurring. But we are still left with the case 2 when an exception occur but not handled by the catch block, and the case 3 where an exception occurs and is handled by the catch block. All these these two scenarios along with other details on exception handling will be covered in the next lecture. Here is a list of references which is being used for the preparation. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.